In order to write programs that involve data analysis, we need some way of getting data into our programs. In this video, we're going to take a look at a common data file format called the CSV format, which is short for comma-separated values. It's a very popular file format that every spreadsheet software and database software can produce and work with. That languages like Python also have common standard libraries you can use in order to work with these files. So let's take a look at a very simple CSV to understand what it is we're working with. Here you can see an Excel spreadsheet, and you can see a very simple data table where I've got 3 columns, each has a header, and then there's some data associated with those columns row by row. So maybe we're thinking about a very simple weather example where we're looking at the weather forecast for the upcoming few days, and we see that there's a low of 56 and a high of 75 on the 16th of October. So in Excel, you have the ability to save spreadsheets as, and you can see in this dropdown, normally you would be working in an Excel workbook file format with a .xlsx extension. But one of the common formats that you might also use otherwise is a comma delimited or CSV file. With Google Spreadsheets, you can also save your spreadsheets as CSV files. And what that looks like when you actually look at what is in the contents of a CSV file is something like this. And notice that there's a close relationship to what we saw in Excel. We have our headers on the first row, and notice they're separated by commas, and that's where the name of this file format gets its inspiration from. We're separating each of our values with a comma. And then each of the rows, similarly, we have the first column for the first row is the 16th of October. The low for that day is 56, the high is 75. You kind of get the point. So we're going to be working with this very simple data file, and I think it's one that I tried to choose in specifically such that it would be easy for you to replicate. And let's go ahead and set up a special data folder in our project. So in your workspace, if you look for the new folder button at the very top, so click outside of any other folder. So you don't want to be inside of any folder or have your cursor on anything. So you can close those and then click outside and press the new folder button. And you should see it as what we would think of as a sibling to your exercises and lessons and projects. It might help to collapse those folders down so that you don't see all the files in them. And then when you press new folder, you should get it at this top level, and we'll name it data. Inside of that data directory, go ahead and select a new file and name it weather.csv. And I'm just going to, for my purposes, copy and paste this example that we had from earlier and save it. So I'll make this a little bit larger. And if you want to just go ahead and pause the video here for a moment to get this CSV file set up in your data directory. So this was in the data directory. You shouldn't see anything in front of data. This shouldn't be in lessons or exercises. It should just be in a data folder, and then weather.csv. So go ahead and get this down, and then we'll talk about how do we actually read this data into a Python program. All right, so now that you have that going, let's go ahead and set up in our lessons directory a file named datautils.py. And in datautils.py, in the lessons package, I'm going to name this or add a doc string here that describes what's going on and some helpful utility functions for working with CSV files is what I'll add to the top of this. And the very first function that we're going to write is one where we read the rows of a CSV. So let's go ahead and define a skeleton function here. So def read CSV rows. And what we're going to do is we're going to give it the name of a file. So file name, which is a string. And this is where we're going to load the data in from our computer. And we'll see that this is going to reference this weather.csv that we set up later when we go to actually use this function. And this will be a function that returns an interesting type. It will return a list of dictionaries where the key type is string and the value type is string. Okay. So in other words, we're going to return a list of the rows, and each row is going to be represented by a dictionary where the column name is the key and the value associated with that key, or the column value, or the row value will be the second, will also be a string. So let's add a doc string here, and this is going to read the rows of a CSV into a table. Right? I'm going to put table in quotes because it's really just a list of dictionaries. Okay, and for now, let's just return the empty list. Right? We can do a little bit better than that. We can maybe set up a result list, and that's going to be of type list dict string to string, and that will be the empty list, and we'll return result. Right? So to do more work, right? So we have some work to do to actually go and read a CSV file in and take each of its rows, read them in row by row, and add them to the result list. But we'll come back to that, right? So what we're doing here is we're setting up a utilities file that will have some functions that we'll get to use, in this lesson as well as in an upcoming exercise. Great. Well, we'd like to import this function elsewhere. And so we're going to be working in a Python or a Jupyter notebook that will allow us to import this data utils module and make use of its functions. So in your lessons directory, the next thing I would encourage you to do is go ahead and say new file. And in the lessons directory, set up a file named csv_demo.ipynb. I've already gone ahead and set up this file in my workspace, and I'm going to open that up. Right? What I'd like you to do, I'm going to make this a little bit smaller and get out of the way here, is in just a moment, go ahead and pause the video and set up a markdown cell and a code cell and another markdown cell, and pause the video and get these set up in the way that I have them so that you have some notes about what's going on. Okay, I'm going to go ahead and let this text render as actual formatted text rather than the markdown that you were seeing before. And we should talk a little bit about what's going on here. So we're setting up a Jupyter notebook that has some text that's describing what's going on for notes and for reference if we come back to it. This first cell is kind of special. So if you recall when we were talking about a Jupyter notebook, when we actually go and run a kernel, and you should see in this upper right-hand side, Python 3.9. some other number. If yours isn't 7, that's okay. If you don't see that, if you see something like, select a kernel, go ahead and click it and then select your Python 3.9 kernel, and that will get it running in the background. And when your kernel is running, remember, until you restart it or close your notebook and reopen it, that same kernel is running all the time. And what we learned about importing is the first time you import a module, it loads that module from scratch. And then subsequent imports, it just says, hey, I've already loaded this. Let's go use what we've used before. But what we're about to be doing is working on our functions in datautils.py and then making use of those functions and actually calling them from our Jupyter notebook. So we want our module datautils to automatically reload each time we save and make changes to it so that the changes we make there are reflected in our notebook without us having to restart our notebook every time. And this sort of special incantation of loading an extension called auto reload, and then we're using a special mode of this, which is like effectively always go and auto reload whenever there's a change. And then printing a little message that describes what's going on is good practice. So I'm going to go ahead and execute this cell. I'm going to use the shortcut and press Control Enter to do so, and boom. All right, so it tells us that we've enabled auto reload, and we're going to need to be sure to save our module when we make changes to it. So we've got a note here below this that we're going to import some utility functions. Let's go ahead and add a code cell below this, and let's import this function. Now, as you recall, when we're working in a Jupyter notebook, we can import other modules and functions in those modules relative to the package we're in. What I mean by that is we can say in this notebook from datautils, import read CSV rows, right? And if I were to now, evaluate this cell, there's no output, right? We've just effectively loaded read CSV rows into memory, but we need to actually make use of it. So how can we do that? Well, recall that we need to, in order to call this function, we need to give it a file name of the CSV file that we're hoping to load. So let's go ahead and store that file name in a variable. So data file is going to be a string that is assigned. And here you're going to see me use some slightly funky syntax. I'm going to say 2 dots and a slash. And what I'm doing here is notice that this Python notebook is in the lessons directory. When we use 2 dots in what we call a file path, that's saying look up one directory. So go back up to the parent directory, which is our workspace. And then we're going to say go look in the data directory for the weather.csv file. Okay. And so what we're doing here is effectively setting up a string that's called a path that allows us to reference the file weather.csv from within the context of this Python notebook and this Jupyter notebook. Okay. And so now what I might do is set up a variable named data table. And this type will be a list of dictionaries that is from string to string. And it's the result of calling read CSV rows with the data file string that we just set up, right? And the very last thing we'll do is print out what is in this data table, right? And remember that the last statement, the last line of code in a Jupyter notebook, if it's an expression, it's going to try and take that expression and render it just beneath the output or as output of this cell when we evaluate it. So I'm going to press Control Enter, and what do you know? We get the empty list. And that makes sense because over here in data utils, all we did was we set up the result of this function call to be an empty list, and we returned it. So we have more work to do. We haven't yet implemented this function, right? But we have made it to the point of being able to call this function. And so now every time we press Control and Enter, boom, we get to, we load that, we call that function again. So I'm over in data utils. Let's actually do some work. Before we can work with CSV files, we're going to need to open this file from our hard drive or from our storage. And there's a special function that's built into Python for doing so. Let's set up a variable named file handle. And normally, when we declare local variables, you would see me add a specific type here. Because this is getting a little bit more nuanced, I'm going to let Python infer this type on our behalf for the time being. So I'm not going to worry about the type of this variable, but it's just a variable. And we're going to assign it the result of opening the file name parameter. Right? So this file name came in as a parameter. And I'm also going to give as a second argument to this open function call the string R, which is kind of cryptic, but it's short for read. We're going to be reading this file in from our disk. And then I'm going to use one last kind of funny looking parameter that involves a concept that we haven't really talked about yet called a keyword parameter. And that is encoding is UTF-8. Right? And so what this is doing is saying there's lots of parameters to this open function. If I were to hover over it, you see, there's many different parameters we could use. And advanced Python functions that have lots of potential parameters use this special parameter concept that's very specific to the Python programming language that allows us to say, hey, this specific parameter, I want to give it this specific value. We really don't need to worry about the details of this. Whenever you need to figure out how can I open a file in some programming language like Python, you should just go Google it and you'll recall these and learn these special pieces of syntax you need in order to make it work. All right, so we've opened a file and next we're going to need to read that file. But one of the things that we need to remember to do is also once we're done reading it, we want to close it. So I'm going to go ahead and make that call to the close method of the file. And maybe a note here to close the file when we're done to free its resources. All right. So just like if you take some tool out to work with it, when you're done with it, you want to put it back. When we're opening a file in our system, we're using a resource from our computer's operating system. When we're done with that resource, we should finish. We should say, hey, we're done. And when we're using a file, we open it and we close it when we're done with it. So between those two steps, we now need to read that file. Well, before we go and read this file directly, we need a way. So when we open a file, normally we would just read it in line by line, just strings of text at a time. And that's pretty common. But we're working with a CSV file. So we need something that will allow us to read each line of our CSV into a dictionary. And Python has some built-in capabilities for that in the CSV package that comes standard with the Python programming language. So we're going to import from CSV a dictionary reader. All right? I'm going to add this import to the very top level of my module. And CSV is a package that's built into the Python programming language. In fact, if I were to copy this and just go search for it really quickly, you would see in the standard docs.python.org, here's the CSV library, and there's lots of great documentation about it. And if I were to search for dictionary reader, we would see that this tells us a little bit how to use it and even gives us an example of how to use it, right? But we'll be working through this as sort of a follow-along tutorial. So what we need to do here is set up our CSV reader to be a new dictionary reader. And we're giving it this file. We're saying, hey, from this file handle, set up a dictionary reader that will allow us to read the data into our program row by row. Okay. Now you'll notice I didn't add a type to this variable either, but if we were to hover over it, you'll see that its type is a dict reader of strings. And if we were to hover over file handle, we would see that its type is a text IO wrapper. All of that is more detail than we need to know in order to do our jobs. We're using some built-in library functionalities. And when you need to do that, typically you're referring to reference on the internet in order to remember some of these details or learn these details for the first time. Great. Now that we have this reader, we can do something really cool, which is we can loop through each of the rows. So for row in CSV reader, row is now going to be assigned a dictionary of string to string where the key is the column name and the value is the value for that particular row. Well, what do we want to do? Well, we want to append that to this resulting table. All right, so result.append this row. Right? And let's just add some comments here. Read each row of the CSV line by line. And maybe we'll set up, let's just add some comments to these lines as well so that we describe what's going on. Open a handle to the data file. Prepare to read the data file as a CSV rather than just strings. And then we've got comments on the rest of this. Now, you want to be sure to save this module, right? So notice that I just did that sort of instinctually. I had this circle here, I saved it, boom. And now, supposing everything we did here was correct, we should be able to go back to our Jupyter notebook and reevaluate this cell. So I'm going to press Control Enter here. And boom, what do you know? Look at this. Remember, we were calling that function. We were saying, hey, go load this CSV file from the data directory. And look at what we've got here. We've got a list where each item in that list is a dictionary. And each key is a column name, and each value associated with that key was, that row and value, or that row and column's value. So we've successfully read the data in from this file to our running Jupyter notebook and wrote a program, a little file, or we wrote a function that we can reuse in the future to read other data files in. So that's pretty cool. Just to convince ourselves that, hey, this is actually loading data, what if we tried changing in the CSV file the high on 10/18 to say, or let's just add one more day, so 10/19. And let's say, I'll make this up, it's a low of say 64 and a high of say 79, right? So I add one more row to my CSV and I saved this file. And now if I come back to my Jupyter notebook and press Control Enter to reevaluate, boom, look, now we have 4 rows. So you can kind of get the sense that, yeah, we can have data files that you're presumably working with in a spreadsheet or some other database. We can export that into the special file format, and now we know how to read that data into a Python program. One of the things I want to remind you of is that even though we are evaluating these cells and seeing output in real time, remember when you're working in Jupyter Notebooks, your progress is not saved in this file until you intentionally save it. And you can see that again with this circle at the top. So as you're working in Jupyter Notebooks, be sure you're saving the work that you're doing such that you can come back to it later and you're not going to lose any work. All right. So now that we've read this in, maybe we want to go a little bit further and see if we can analyze a specific column's values. So notice that each of these, maybe what we want to do is change the representation of this table from a list of dictionaries to perhaps where each entry is a row, to maybe thinking about this in a more column-oriented format. And as we move forward, we'll learn that working in a column-oriented format is more convenient for doing the types of analysis data scientists typically want to do. So towards that direction, let's maybe write another utility function that will allow us to pull out all of the values for a specific column. So the function we're about to try and implement is one where, let's say we wanted all the values for the date column. We would get back just a list of these strings. How could we do that? Well, let's start by defining a skeleton function in our data utils module. All right, so I'm going to go back to data utils and define a function that is named column values. And it will take in a table that is a list of dictionaries from string to string, and a column, which is our string, which is a string. It's the name of the column that we want all of its values for. And it's going to return a list of string values. Okay. And let's add some documentation, which is just to produce a list stir of all values in a single column. Okay. And let's make this a valid function, a valid simple dummy function. I might name a variable result and set up its type as a list of strings, empty list, and return that result. Okay, and we've got work to do. So we have not yet correctly implemented this function, but we've at least set up the skeleton of a working function. And now we can go set up some code in our Python Jupyter notebook that will call this function and evaluate its results. Okay, so once you're caught up here, join me back over in the Jupyter notebook, and let's go ahead and add a new markdown row. So I'm gonna add a new markdown cell and set up another heading here. So an example of selecting the values of a single function, of a single column, sorry, with column values. And I'm using backticks there, and you'll notice that when you use backticks, you get this nice sort of code-looking formatting, right? And now I'm going to add a code cell. Okay. Well, we've just set up a new function, and we need to import it. So from data utils, import column values. Okay. And let's go ahead. So we've got this data table variable, and notice that's going to correspond to the first parameter that we want to use with this function. So let's maybe set up dates as the resulting variable that we're going to store the result of this function call in. It will be a list of string values, and it's going to be the result of calling column values with our data table. Remember, that's the variable we set up earlier in our Jupyter notebook. And we're selecting the column date. Okay. And then I'll use as the last expression in the cell, just dates. So when I run this, what do you know? We get the empty list. Okay. So we know that this function call is correctly working because this is calling the dummy function. We don't get any errors. And so now we're ready to, I'm going to go ahead and save my Jupyter notebook, best practice. Now we're ready to try and implement the correct implementation of this function. So what are we trying to achieve with this function? Well, remember, we've got, our data is going to look something like this. We've got a list, and each item in that list is a row, okay? So we know right off the bat, we're going to have to loop through each row in this list, and we know how to do that with a for in. And we also know that we want to do this over every item in the list. So let's go ahead and set up a for in. And so for row in our table, right? So our table, remember, is the list of dictionaries. And so now row is a dictionary where the string is the key and the value is the row column value associated with it. Okay. Well, how do we access the item that we're looking for? Remember, if the key of this row, it represents the column, and the column that we're trying to select was passed in, like the string value, the name of the column that we're looking for was passed in as a parameter, we can do something like item string is, stir is assigned row, and then we're going to use the key column, right? And so remember, column in our example, if we looked back at this function call, was the string date, right? So on this row, this is the dictionary. If we looked up, okay, well, what is stored at key date? That would be the value 1016. And then the next loop of the for in would say, okay, well, what about this row? The key that we're looking at is date, and that would be 1017. Okay, so now we have this item. Well, what do we do with this item? Well, we're going to just add it to our result list, because the point of this function is to move through row by row and say, okay, take some column value, take the value stored at that column for that given row and add it to this list. So result.append this item, right? I'm going to save my module and jump back to my Jupyter notebook to try testing this out. Remember, saving is important here so that the changes will be reflected when we try rerunning this particular cell. So I rerun my cell with Control Enter, and what do you know? We get a list that has the entries 1016, 1017, 1018, 1019. And so we've effectively written a function that takes a data table and a column and gives you back a list of all of the values for that particular column, coming from a row-oriented modeling of that data. That's pretty cool. We could change this string date to be, say, the column low, and notice that we get back the values from the low column, right? And hopefully the mechanisms for this are making sense. But notice, we're getting back these 4 values in our list. And that's because we're saying, hey, select the low column from data table using this function we just defined, okay? And we could do the same thing with high, right? 75, 76, 75, 79. We change the column that we're looking for to high, and boom, we get those values back. So you're kind of getting a sense of the process that will be very common when you're developing some functions and testing them in data utils. And this was a pretty straightforward little function that's just kind of clever, right? In how we give it the first table, which is a row-oriented representation of our CSV, and the column name. Well, let's add one more function that will complete this transition from here we have a representation that's a list of rows. What if we wanted a representation that was a dictionary of columns, right? And we'll spend some time in the lessons ahead thinking a little bit more deeply about some of the trade-offs here. But the idea is, it's pretty, notice there's a lot of repetition. The word date, the string date, is occurring on every single one of these rows. That string has to be stored in memory. If you tried to write out and imagine diagramming this particular list of dictionaries, you'd be writing the word date a lot. Maybe it'd be nice to try transitioning a row-oriented representation of this table to a column-oriented representation. So what I mean by that is, let's have a dictionary where the keys are the column names, and then the associated value is a list of all of the row values for that particular column in our table. So we're going to define one more function called columnar. Okay? So this is kind of a funny function name, but def columnar. And we're going to give it a row table. And that's just the same type as we've been working with, a list of dictionaries from string to string. And it's going to ultimately produce a column-oriented table, which is going to be a dictionary where the key type is string and the value type is a list of strings. Right? So once again, we're going to add a doc string here that will tell us a little bit about the purpose of this. And the purpose of this particular function is to transform a row-oriented table to a column-oriented table, right? Or representation of a table. Okay, and let's once again set up sort of our skeleton code here that will allow us to call this function and convince ourselves that we're on the right track. So my result here is going to be actually this type, right? This is the type of data that we need to return in order for this to be valid. So I'm actually just going to copy and paste that. So a dictionary from string to list of string, and I'm going to use just the empty dictionary literal in order to initialize it. We could have also said dictionary constructor. Either way is fine. I prefer using the literals, but if you'd prefer the function call, that's up to you. And we'll return our result. Remember, this is just setting up sort of the skeleton code here. And to do more work, right? So we haven't yet taken our row-oriented table and converted into a column-oriented table. So we've got to do that next. But before we do that, now that we've set up our skeleton, we should be able to import this function into our Jupyter notebook and try calling it there and setting up a little example of that. So I'm going to jump back over to my Jupyter notebook, and I'm going to add another markdown cell and add an example, or add a subheading that is convert a row-oriented table to a column-oriented table. And I might even put the words table in parentheses or in quotes, because these aren't actually tables; these are just representations of tables. And we're using lists and dictionaries in clever and creative ways to represent the idea of a table. So beneath that markdown cell, let's add a code cell. And we're going to go ahead and import our function. So from data utils, import the columnar function. Okay, cool. Now we want to call it. And let's add so our data table that we're going to try and convert from rows to columns orientation is named data table. So maybe we'll name this column table. And what's its type? Well, its type is going to be a dictionary. Our key type is the string. It's the name of the columns of our table. And the value type is going to be a list of strings, which are all of the row values for that given column. And we're going to assign to it the result of calling columnar, which is the function we're about to go implement. And we need to give it the data table. So data table. Okay. And by a Jupyter Notebook convention, we'll say the last expression in the cell is column table. So that when we call this function, or when we evaluate the cell, I should say, we get the empty dictionary literal printed, and that gives us some confirmation that, yeah, sure, of course, this is calling our skeleton function. It's giving back the empty dictionary. Now it's time for us to go work on that function and correctly implement it. Okay, so I'm going to save my notebook, make sure I don't lose any progress there, and let's jump back to data utils. So how do we convert a list of dictionaries or a list of rows to a dictionary of columns? Well, we just wrote a column or a function that will give us all of the values for a single column. So maybe what we need to do is loop over all of the columns and call this function such that we can get back all of the values for that specific function and make some reuse of this function we previously implemented. That's kind of a mouthful. So let's work through this together. Right? So we need the keys. We need the column names. Right? And where would we get those from? Well, the column names can be found by looping over the first row. So maybe we say first row is a dictionary from string to string, and that is row table index 0, right? So remember, our row table is this list of rows. And so if we look at the first row, then we have a dictionary, right? And we know something about dictionaries that will allow us to loop through all of its keys, right? And remember, the keys of this particular dictionary are the names of the columns, right? So again, if we want to just remind ourselves what we're going to be, this first row would be this dictionary here. And so the keys are date, low, and high, right? So I might say for column in first row, what are we going to do? Well, we want to grab all of the values for that particular column that exist in this entire table. And that's the point of this function that we previously wrote, right? So we can say, okay, let's set up, insert into our result dictionary. So the result column is going to be assigned the result of calling column values, where our table is row table and our column is the column we're looping in, right? So I'm going to save this. And there's a lot of magic, or I shouldn't say magic, but there's some pretty high order concepts happening here that we should understand. There's also something we should be careful of. And maybe you've spotted something that might be erroneous. We've made the assumption that this table wasn't empty, that there are in fact at least one row. So we would have an index error if we passed in an empty row table. We're going to leave that concern for some other video and not worry about that here. We're going to assume that we're giving a non-empty table to this function. But we're pulling out the very first row in order to access its keys, right? So that first row is a dictionary. And each key is what we think of as actually a column. So rather than calling this key, I'm just going to call this variable column. Same thing. It doesn't actually matter. We can name this variable in the for-in loop, whatever we'd like. And then we're saying, okay, go find all the column values in this table for that particular column. And that's going to make use of the function we just wrote, right? The one where when we called column values with the high string, it gave us a list of those high values. And so we'll do that for each of our columns. And we're going to insert into our result dictionary for that given column all of those values that are stored in that list. Finally, we're going to return that result. And that's going to give us this dictionary. So if we are somewhat correct in our logic and we rerun this example, notice now that we're getting a column-oriented representation of our data back, where we have a dictionary. And each key in that dictionary is a string. And then each value is now going to be the subsequent rows for that particular column, right? And notice that this is, if we look at the amount of data that was required to model this orientation of our table versus this orientation, there's a lot less redundancy. And the other thing that's really nice is now we have a single list of all of the values related to, say, the low temperatures. So if we wanted to do some computation, such as like find the average or the lowest temperature or the highest temperature of one of the of this entire data set, we would have a single list that we would be processing of what we think of as like very coherent data. We could convert all of these values to floats or ints and then run that computation. Whereas before we would have needed to worry about, oh, well, each row, we got to go look up the specific key to get its value. And our algorithms would have needed to be a little bit more precise to or custom fit to our data set. Here, once we have columns that are just integers, it'll make processing a lot easier once we convert these strings to integers in a data format we can use more readily. So in this video, and I should be sure to save, we've taken a look at some important concepts when working with a CSV file in order to start doing some data processing. We began by loading a CSV file into our program. And we wrote a utility function to help us do that, right? And so every programming language is going to have a nice way of taking some CSV file and loading it into some representation. And here we started off with what was most simple, a list of dictionaries where each dictionary had a row of data. We then wrote, a little function that allowed us to pull out the individual values for a single column and brought that all together into a function that could translate a row-oriented representation, a list of dictionaries, into a column-oriented representation, a dictionary of lists, where each list is an entire column's worth of values. In an exercise ahead, we'll start to take this even further and to start doing actual analysis on a data set. These are just some functions that helped us get to a point of making it easier to work with our data and representing it in a way that would be more readily processed. So great work on this. And hopefully you've now got an example of being able to load data that we made in a spreadsheet into our program so that we can start doing interactive data analysis.